Last episode, we sorted things into sets. Now take a set of numbers with an order and ask, what if the list never ends? Where does it head? Picture pouring half a glass of water, then half of what's left, then half again. Each pour is smaller. You never quite overflow, but you get closer and closer to one full glass. The pours are a sequence. The total poured is a series, and one full glass is the limit it approaches. So a sequence is the list of terms, 1/2, 1/4, 1/8, and the series is the running sum after each step. The key quantity is the partial sum, how much you've accumulated so far. We watch whether those partial sums creep toward a fixed number. When the ratio between terms is r and the absolute value of r is below 1, the infinite geometric series sums to a divided by 1 minus r. Each term is smaller than the last by the factor r, so the tail vanishes and the total converges. That approaching a value is what a limit means. This is the spine of ML. A training loss over epochs is a sequence. We want it to converge. The derivative behind gradient descent is the limit of a difference as the step shrinks to 0. And in reinforcement learning, the discounted return is a geometric series, rewards multiplied by gamma to the power of how far away they are. Here's the whole thing in one file. We sum a geometric series, term by term, watch the partial sums converge, and compare to the closed form limit. We set the first term a and ratio r below 1, then build the sequence of partial sums. We use NumPy's cumulative sum to get the running total after each term. We compute the closed form limit over 1 minus r, the value the sum is heading toward. We print the limit and the gap between the final partial sum and that limit, showing it has nearly closed. We plot the partial sums as rising dots against a dashed line at the limit. The dots crowding the line is convergence made visible. The limit is where approaching becomes arriving. Next episode, we leave one number behind and learn to carry many at once. Vectors and vector spaces.